Hello guys, I hope you are doing good. Today let's understand how we can tackle obfuscation using log commands. Being a malware researcher, obfuscation is something you'd like to see at the end. I really hate it when I come across heavily obfuscated malwares, especially Android malwares. So today let's understand how we can use log commands to tackle the obfuscation up to some extent. So here I have made a sample app which is basically a app which sends SMS, and consider a SMS Trojan which is sending messages to some number and with some particular message. Let's just write on this application first. I have this device which is running here. So first of all, yeah, it's a success. And here is the app. What this app basically does is it sends a SMS to some number with some particular message. If you click on this button, it will send some kind of SMS at the end. Yeah, you have to allow this. Let me allow it quickly. And once you click this button, it will send an SMS and saying sending message. So as a malware researcher, this is just a sample app that I have made for this exercise. But consider a scenario where an SMS Trojan is sending message and you want to reverse it to find out what exactly is behind the code. So let's just quickly reverse the app. So basically I have this quick script that I have written, which fires APK tool as well as dex2jar on the malware. So this fires this automation fires this command, initially APK tool, and secondly it will try to, just wait a second, just let us, yeah, and secondly it will do dex2jar, and just give a second to the script. This is basically a simple automation script which fires APK tool and dex2jar. I get both of the things at the same time. So let's clear this out, and here this is the output of APK tool, and this is the output of dex2jar. Basically we want to see what exactly the Java code is. So let's see what I basically do is I specifically start my analysis from Android manifest.xml. This is a very simple app which has one activity, as I told you. This one simple activity having a button, and basically it has this permission which sends SMS, and that's it. The package name of the app is com.example.fake app. Now let's try to understand what the code behind this specific app is doing. For this specific thing I prefer to use either JD-GUI or JD-GUI. Uh, so as we initially saw, the package name is com.example, and here is the main activity. To make the exercise more interesting, I have used Enigma as an obfuscation script for obfuscation, and if you see here, it's pretty much good obfuscation done by Enigma. In here, if we try to see send text message, here it is. So on click, so as I told you, as soon as we click on the button, it tries to send SMS. But if you see here in send text message, there is a string and there is a local object. So basically, if you understand, let me quickly show you SMS manager. So this is the syntax of text message, sending a text message in Android. First is destination address, second is source, third is text, this is the intent being used, this is the delivery intent, and message ID. What basically we want is the destination address, especially, and secondly the text. These two are the important juicy things in our case here, what we want to know. But if you see, the code is pretty much obfuscated, and if I want to know what message is being sent, this is the message and this is the string. So basically this is the phone number where the message is being sent, and this is the message, the actual message that is being sent. So if you see here, it has done pretty good obfuscation. Local object is basically string again, and it's pretty messed up over here. Okay, so what can we do here is, it's pretty much messed up. This is the last thing malware researcher would like to see. Again, if you see, it's heavy obfuscation. This is basically lock.d command, some kind of command, and if you see here, this is some kind of AES. So let me tell you, I have written this code myself, this main activity, and this particular thing is completely garbage text. This is just trying to route a malware researcher towards something else. Here, using secret key spec, AES, PKCS padding, the code is, the developer is trying to redirect us towards some kind of encryption being used here, but trust me, there is no encryption I have used. So in this case, what can we do is, a very simple thing would be to use log commands, log.d, right? D is for debug. You can use I or error, whatever you use, whatever you like. I prefer log.d. So what we can do here is, just before send text message is being fired, we can use log.d command, and then we can try to print out this thing over here. So let's try to do this. Let's see how we can achieve this. This is a really good article, I would say, payloadgabber.uw.hu. This is a pretty old article, but still very informative for understanding smali. So what basically smali is, we'll try to when you reverse the code, we'll get the intermediate code in form of smali files. So if you see here, the output of APK tool, this is what we get. It decompiles this thing for us, and if we go in the smali folder, according to our package name, it should be example.fakeapp, and here is main activity. So what we can do is, we can try to open main activity.smali, and this is basically all you will have to tackle about. So I suppose this is very short. Let me quickly open up this one. Yeah, I suppose our code has to be in this one. Yes, this seems to be pretty big enough, lengthy file. So this is what our code, this is the file where our code resides. So in here, send text message, if you see, this is send text message, and yes, in order to use this smali recommendations and use log.d commands for fighting or for overcoming obfuscation, you will have to have little knowledge of smali. It's not a big deal, you can easily understand smali from the site. It just basically gives you complete good explanation with examples and what the opcodes mean actually. So for log.d command, we will be using invoked static. Yeah, this is the command that we'll be using. It basically calls the method with parameters and fires the output. So one easy trick I can tell you, if you really don't want to go much into detail, definitely this over here, if you see, this is using log commands a lot, but okay, using this won't be a good idea. But what you can do is, you can write a simple APK file, Android project in Android Studio, use log.d command or whatever commands you are interested in, build the APK and just reverse it using APK tool, and you will get exactly smali code of the app, and from there you can use a particular syntax of that command. Say for example, see here, if you see, I got an example right in front of my eye, log.d. We'll be using log command. So basically, invoke static. Secondly, it will pass the parameters. Thirdly, the full package name, or you can say of log command. So basically we use for log, if you have noticed, we import android.util.log, and in later part we do log.d, and here comes tag, and here comes, say for example, a message or a value. So this is a very basic understanding of log command. So in here, if we see, this is a good example. We can just directly use this in our understanding. So see, understand, over here if we go send text message, uh, I think so there are two send text message I have used. Yeah, one over here and one over here. Basically this is was a very raw code. I was trying to achieve this in very short amount of time, so I had to use this try catch on both if else loops. So here if you see, this is the try, this is send text message. We want exactly our code to be here, so we can search for send text message in our smali file. Here it is. So what we can do is we can try to input our smali commands over here, and by saying smali command we just need 2 or 3 lines. Basically we can just use invoke static over here. I really don't want to mess up with this syntax, so let's just completely copy paste this. Now the important thing to understand here is send text message, this is complete syntax of send text message. So as I told you, let me quickly write it down for you. Send text message. So first of all, we will be using destination address, or I can say phone number. Second is source address, which is specifically null most of the time I have noticed. Source address is basically the phone number of my phone. Basically if I am sending a message to someone, then this will be someone's number and this will be my number. Especially this is null most of the time. This will be the actual message that is being sent. And secondly, there will be two types of intents, as we told, as I saw in this thing: text sent intent, delivery intent, and message ID. So this is basically sent intent and delivery intent, I think so, are used for this delivery confirmations, but we really are not interested in that. The set intent and delivery intent and say ID. So we basically need this. And see, this is first parameter, second, third, fourth, fifth, sixth. And what I have noticed is in smali file, they use this kind of self this thing this as the command over here, send text message. So basically from v2 to v7, let me quickly copy this thing. So in smali they also, I suppose this is the self reference that they make, and hence there are 7 parameters being used in here. So if we see our example over here, send text message example, it is using v2 to v7. So this is the important thing, guys, try to understand. v2, v3, v4, v5, v6 and v7. So understand what I told you. This is kind of a self reference, you can correct me if I am wrong. This is used for this. I don't know why exactly that is done in smali, new to smali, but somewhere down the line in smali file we don't need the first parameter. Second, so basically this all are over here, so we understand we need second, third and fourth, second and fourth. So basically if you see, this is our second parameter, so this has to be the destination address, or I can say phone number. This is source address, we don't need it, so just ignore it as of now. And v5 is basically this, so this is the message, and as of now just ignore this v6 v7 as well. v4 also we don't need it, and v2 is self reference, I can say. So we basically need v3 and v5. So in here, if please understand, if it was v1 to v6, then our this syntax will again be changed. So this would be v1 v2, so v2 and v3 will be again the interesting part here, what we need. But in our case here, if we see into smali code, it's v2 to v7. So this is basically an important thing to understand. So here what we can use is basically here coming again log.d. So this is basically log.d, which fulfills over here log.d, and in it we have to pass two parameters. So please understand, two parameters are, first is the tag that we want, second is the message or the value. So in here the message or the value, we need v3 and v5. So we can use two log commands, definitely, one for v3 and one for v5. So here this is complete smali syntax for log file. Secondly, we want a tag over here. So what you can do is constant string, say I suppose v1 we can use it. I suppose it should not create any problem, and we can name it as shiv. Okay, and we can use the tag. So we have the tag, and we want v3 as the destination address, basically phone number. So we can use in here is v3, correct? I hope you are getting. If you don't understand anything, just include anything in the comment, and I'll try to solve your doubt, because these small things are a bit confusing. I agree. I had to spend my whole weekend on this. So v1 and v3, and secondly again we can copy this, and in here we can use what, the message that we want. So basically v5. So we can use v5 over here. This looks good. And guys, understand there are two syntax message over here in the code. First one is this, and there were some permission issues, and the code was jumping from here and there. So I what I did as a simple solution is I included this again outside the if loop. So there is second text message. So what we can do is we can search for second send message in the smali file. Here is the first one, and here is the second one. Again, I suppose there should not be any issue in using v1 and v3, I suppose. Yeah, v1. Okay, fingers crossed guys, there shouldn't be any problem. Sorry. So v1 is the tag. Let's just constant string v1 show. This is just the tag that we will be using in adb logcat command while tracing the calls. And again, see here it's v2 and v7. So v3 will be our destination phone number, and v5 will be the message. So constant string, again the syntax is very important. You can find it over here, or else again you can reference it here. Yes, we have constant string. I was just making sure that there is no syntax or some kind of spelling mistake here. Okay, so as this is done, I hope you are understanding the whole process. First, what we did is reverse the app. We read the smali code, we added log commands in the smali file. Now what we'll do is we'll try to recompile the app, recompile the APK. Make sure to save this thing, smali file. Sorry for that. We can do over here APK tool, we can use B for recompiling, and here we go. We'll have to wait some time for this. It sometimes it takes a little bit of more time, and this is the video I'm shooting directly. Oops, at the first go. Right, relay, building resources, home, no resource identifier found. Okay, yeah, see, as I told you, right, this is the video in one go, so we might come across such type of exceptions and issues or my fumbling. What we can do is, this is a very common scenario that I come across while analyzing malwares. So what we can do is, this APK tool is giving us an exception, and basically if I'm not wrong, it is trying to find something in the resources folder and giving me a hard time over there. So a very straightforward idea is to, while we fired the command APK tool via my automation script, the command fired was just simply to decompile the app and .apk. This is what the command was fired. What we can do here is, we can just skip out the resource folder. We don't want resource folder, as it's not of importance as of now. So just let me remove this thing first of all. Yes, we can fire APK tool again with -r. So basically removing the resource. We don't want to decompile resource folder. We can keep it as it is. Fake. Let me quickly do it. Oops, sorry. And decompile. We need to decompile it. So again, yes. This is done. We have our fake app again folder. We can again go, and we'll have to basically do the last step again, but let's smali com example fake app main activity. Okay, so quickly let me copy this file, this thing, syntax message. Oops, okay, it automatically, it's okay, we can do it quickly once again. I was trying to copy the invoke this thing, but it it reloaded. I think so. Sublime reloaded it. Okay, fine, no problem. We can again constant string v1 shift, and let me just copy this over here. V, what we want is the tag. Secondly, what I told you, v3, and again v5, v1 5. I suppose we are good to go. Not yet. This is just done for one. We need to do it here as well. Why do I make such mistakes again and again? Okay. I hope they should work. Fingers crossed. We have saved it, and let's go back to more apk2 and to recompile it with the directory this. I hope there should not be any issue now. Ideally this solves the problem. Yes, copying raw sources, as I told you, if we use -r, it won't do any changes during decompilation. It will not hinder the resources folder, so it is copying the raw resources as it is. And I think this the exception that we saw earlier was because of the obfuscation that we used. As you know, as you see here, the APK has been built. So let's get the APK. Yeah, in the dist folder we have our fake app, and as you see 22.8, so it's basically the app that we want. Now we cannot install this app yet because it is not signed, so please understand, this is out of Android Studio, so it won't allow directly installing the app into the device or emulator. So let's check it. We can use insert command, jar file, and fake app not assigned jar. Okay, so let me quickly uh, just go in and okay, um, here it is. Sorry, I'm not much into remembering the things, commands, as they are already available. So yeah, this is basically my Android certificate that I use for testing purpose. Let's not go deep into how to make a signature file or key store file that's easily available on the net. So I'm not going deep into this, but yeah, definitely if you need to understand, just drop in the comment section below. uh, our file is um, that's the file we want to sign, and yes, that's the perfect. So if we go here and try to fire the same command again, yes, the APK is installed now. Sorry, APK is signed now. Let's quickly go into, yes, it is up and running. AB install fake app, and it should okay, we need to remove this first. You can just use JDB uninstall and the package name. It's done. We can now install fake app again. Yes, the fake app is here, but before doing this, let's first lock it and grep onto the tag that's basically shiv that we define. So what I'm doing is I'm trying to fire adb lockcat, which will give us all the logs that are coming out of our emulator. And secondly, if we see, we have this tag for log as shiv, shiv. So we'll try to grab for shiv. So let's just enter, and this is basically the old testing phase. So below this line you will see what next comes is, it will be the current thing. So let's fire up the app. It will ask for button, and here it is. If you see, just ignore this thing. This is the phone number, and the message is this is secret. That's interesting, isn't it? So basically the phone number is this. This is just a dummy number that I inputted in the sample app, and the message that is being sent is this is secret. So that's how basically you can use lock command to overcome such type of hurdles, obfuscation hurdles. Many a times I have seen where malware developer uses encryption and decryption techniques, basically AES encryption, where a string is being sent to the command and control server, and the it's kind of jumbled up. The malware developer can use any kind of encryption. So this exactly example you can use over there. You can use lock commands to find out what exactly is being sent or what exactly is being hidden from you as a malware researcher. uh, Secondly, this is not only solution or only trick you can use for fighting off obfuscation. Second video I'll be making will be related to a really interesting trick that I found out somewhere on the internet. I definitely will try to find where I found and try to include the source of the trick. but it's really interesting trick. We can use JDX, and then we can open up the profile or open up the particular application in Android Studio, and then we can do lots of good tricks. But let's wait for second video for that. Thirdly, we can use JB, definitely JB, JEB, or JB, whatever you like to say, JB decompiler. It's really good, but one of the cons is it is commercial, and you'll have to pay a hefty amount for JB decompiler. But yes, JB decompiler is really good to fight off obfuscation, which you can come across Android malwares. And definitely at the end you can use dynamic instrumentation using Frida. Frida is the best you can use out there. We'll try to take, what you can do is in upcoming videos we'll try to use Frida and take this same example of fake app 5, and we'll try to use Frida to find out what exactly the phone number is and what the secret is. So stay tuned. Thank you. I hope you like this video.